Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? All right, so make sure today you stay really focused because we're moving along really fast, or should I say not fast, expeditiously. We're moving on to the next concept today, and we don't need any Chromebooks, so you need to put those away, please, pretty please, just so I can get your full attention. Today we're going to get started with our graphing portion of the school year. It starts today and it never ends. So, everybody go like this. Bear with me because we're about to embark in a graphing adventure. All right, I'll give you guys some time for that warm-up. 43 on the screen. Go to you. All right, so this is being recorded. So, just FYI on that note that I just read, this is being recorded, by the way, is that, guys, when I'm not here for whatever emergency that I might have or that I'm here on campus working on stuff with the math team, the way you guys behave in class with other people, other adults, kind of reflects the way I have this class set up. I mean, you guys have the freedom to talk, right, to work, and so on and so forth. But when it becomes disruptive, I'm not saying you, I'm saying when it becomes disruptive, because it's all like, it's not for the benefit for the class, all right? So, with that said, number one, write the compound inequality. What is my first dividing point? We got -1, -2, -3, -4. Let it go. So that means my first dividing point is -4. What's my other dividing point? 1, 2, 3, 4, and 5. So my other dividing point is 5. The solution is where both graphs intersect, which is all of this. So that is what? X. Less than and less than. Let's check for the point. Is this a close point? Yes. Is this a close point? Yes. Now, how do you know, Mr. Q? Well, look up. If this was like this, and you just saw an outline of the point like that, and it was y like that, we don't put the equal underneath, okay? And if we write it as solution set of x such that, and close solution set. All right, let's go to number 2. Number 2, it says solve. Tell your neighbor what common denominator you multiply the entire equation by. Make sure they got it. Now that I asked you to talk, you guys don't talk. What? When you are not asked to talk, you guys talk? What? Multiply times what, everyone? 6, or 6 over 1. Distribute, 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 distribute. That is 12x over 3. Plus 6x over 6 plus 6 over 6 equals -12 over 3. From there, we simplify. This becomes 4x, 1x, 1, and -4. So far, so good, yes? Yeah? All right. So I wonder what 3 Mario's going to bring during lunch. Let's go. Huh? I'm sorry? The note said that you and 3 more people were talking. Or is it you with the 3? Okay, you and 2 more. How about that? Yeah? Okay, good. 5x plus 1 equals -4. From there we solve. -1 minus 1. 5x equals -5. Divide by 5, divide by 5. X equals -1. Hands, have you got that by yourself? Yeah, some of y'all. Yeah. All right. Let's go to number 3. And notice I'm being expeditious about going over this because we need to really get to the lesson. And today we're moving on. Let's go. All right, here we go. Evaluate. So I'm just going to leave it as f of 3 blank minus 2. I need a table. X, f of x. X is -2, -1, 0, 1, and 2. And get used to domain, guys, from -2 to 2 for our graphing, because today we're starting, and anytime I ask you to graph, even if it doesn't say, always assume that the domain is from -2 all the way to 2. All right, here we go. So, -2, we substitute that in here and in here. Is that correct? So we end up with f of 2. The left side stays the same, and we just work on the right side. This is -6 minus 2, which is -8. Let's do it again. Next value is -1. Left side stays the same. 3 times -1 is -3 minus 2. That's -5. Next, f of 3 blank minus 2. Next value is 0, 0, 0. So this is f of 0 equals 0 minus 2, which is -2. So far so good? Yes? Now check this out. From this point forward, if some of you see a pattern, look up. If you see a pattern, you should be able to get the next two values without doing all the work. So you know the next two values for 1 and for 2. What shall we write there and there, if you see it? Renzo's got it. Renzo, what do we write here? 1, very good. How about here? Yes, that is correct. And how do you get that? Well, let's see. -8 plus 3 is -5. Yes? -5 plus 3 is -2. -2 plus 3 is 1. 1 plus 3 is 4. All right, let's graph that. All right, so the domain is from -2, -1, 1, 2, and we go from 1, 2, 3, 4, 5, and we got 1, 2, 3, 4, 5, 6, 7, 8. So we got -2, -8, -1, -5, 1, 2, 3, 4, 5, 0, -2. 1, 1, and 2, 4. All right, we good? All right, copy the agenda, please. Warm-up number 43, 2 variable equations. We're moving on, and hopefully for tonight, 10 problems. As soon as you copy the agenda, go grab 2 graphing papers from the back. They're next to the marker box over there on top of the cabinet. 2 graphing papers. All right, there's a code for tonight's home play access. Okay, once again, access to your home play is W8ALK. W8ALK, write that down. Last night's home play and the previous one were solving rational equations, so I just need you to turn one of those in on Canvas. Doesn't matter if it was yesterday or the day before, one of those on Canvas. Do that right now, please. One of them. Now, I'm assuming that you did at least one of them, right? Yes, Mr. Q. Solving rational equations. Yeah, so the first day it was the even number ones, and the second day on the video I gave you guys also I think like, was it 6? Yes, it was a few. All right. Once again, previous home play was one of those. Turn one of those in. Tonight's home play. Get all that graphing. Let's go. Let's go. All right, as soon as you turn that in, get a Cornell note ready. You do need a Fourier model, the big rectangle, to clarify our concept for today. And here we go. I can define and graph two variable equations. I can define and graph two variable equations. I can define and graph two variable equations. So today, formally, I'm going to introduce the two variable equations because we're on our way to functions. I'm pretty sure you remember, some of you remember functions and two variable equations, but I just want us to be on the same page. Okay? So here we go. So what is our new concept for today? Two variable equations. Two variable equations. So let's write that in the center of our Fourier model. So what is the definition for two variable equations? They are two expressions equal to each other and contain how many variables? Two expressions equal to each other contain two unknown variables. Expressions equal to each other contain two unknown variables. Two expressions equal to each other and contain two unknown variables. Examples: 3x plus 6 equals 3y, 12x equals 4y minus 8, 2a plus 2b equals 14, negative 3m equals m minus 6, and y equals x squared minus 9. Copy those. All right, here it goes. For the sake of time, according to the definition, it says two expressions equal to each other. Let's see. Expression, expression, equal. Yes? Expression, expression, equal. Expression, expression, equal. Same and same. Okay? Contain two unknown variables, x and y, a and b, n and m, x and y. Yes. All right. We good? Yeah. Straightforward. None examples. Before you write them, tell your neighbor why these are not two variable equations. Why are they not two variable equations? Then we're going to pass this to those that were talking and see if they can help us out with this. Let's go. And let's start with Mario. Mario, why is this one not a two-variable equation? It doesn't have an equal sign. That is correct. All right. So pass it to the other talkative person. They said someone from my far right. Oh, Ashlyn? Okay, Ashlyn. Why is this one not a two variable? It doesn't have two variables. All right. Ashlyn, pass it to someone from my far right. Oh, Enrique? All right. Enrique, why is this one not a two-variable equation? Because it has an inequality. Yes, this is a two-variable inequality. All right? So copy that. A couple of hashtags. They need to have an equal sign and two unknown variables. All right, so today I'm actually going to bring back a concept that you guys already know from middle school, or some of you in elementary. I think in elementary. Some of you saw this, I think, 4th and 5th grade. Some of you saw it till 7th or 8th grade, which is fine. I mean, but I'm going to bring it back today, okay? So, we good? So where are we going, Mr. Q? We're going here. Look up. Don't copy this. I'm just going to show you where we're headed. We're going to be looking at forms of linear equations. There's the first form that we're going to be focused on today, known as slope-intercept form. We're going to cover also as well standard form. And once again, all this for linear equations. And the third form known as point slope. Okay? So I'm going to give you the first two just so that you know what they look like. The first one, slope-intercept form, is y equals blank x blank. And if you remember, I gave you this some time back. This is m plus b. That's why this is known as what? Slope-intercept form. Why? Because the m stands for what? Slope, and the b stands for intercept. And to be clear, what intercept? The y-intercept. Okay, how does that look like with a regular equation? It looks something like this. Does that look familiar? Yes. If I was to ask you what is the slope, tell you never what the slope is, please. Enrique? Two. That is correct. Yes, I even aligned it here for you guys. Okay. Pass someone, Enrique. Mario, what's our y-intercept? -5. That is correct. And so on and so forth. We're going to be looking at those today. The other one that I'm going to introduce as well is ax plus by equals c. And this is known as what? Standard form. And what is this one so particular from this one? That both x and y are on the same side of the equation. How does it look like with numbers, Mr. Q? Like this. Let's do 2x plus 6y equals, give me a number, 10. And there you go. Notice that both x and y are on the same side of the equation. That's why this is known as what? Standard form. Point slope form, don't worry about that. We'll get to that pretty soon. And that takes us to this part. Quick intro. Have you guys seen this? Yes, it's a number line. From there was a mathematician, a French mathematician. His name was Descartes. I'm trying to be as French as possible. Are you laughing at me, Mario? Wow. Anyways, he came up with what you guys know as the coordinate plane. However, it's also known as the Cartesian plane because of his last name, the Cartesian. Like if I was to come up with it, I would call it the Cartesian plane. Right, Mario? He said, well, if I wanted to use two different values, I can't stack one line on top of the other. I would do this. Look up. He's all, oh, snap. That gives me two different variables, and you guys already know what they are, right? This is value x, and since this is the second variable, it's valued of y. And notice it came from this side, it went in that direction. That means all of these values are positive, and all of these values on here are what? Negative. And that's where we get that. Okay? So, with that said, get your, can you get the lights, Evelyn? So here's as best as I can introduce this concept. Ready? So here's a Google map for here, for Imperial. And the other day, I was walking out. I finished my tutoring. You guys know there's tutoring after school, right? I was walking out from tutoring, and a parent and their son and daughter stopped me. See us right there? Yep. And they're like, excuse me, do you work here, Mom? I kind of do. Like, do you know where Frank Wright is at? I'm all, oh yeah, let me get my phone. So I got my phone. I said, it's over here. So we're here. Frank Wright is over here. Oh, because I need to register my daughter at Frank Wright. I'm all, okay, so get in your car and just go through all these blocks like this, crash into all the homes, and get to Frank Wright. Get to Frank Wright. Will I give those directions to people? No. I would say this. I said, no, ma'am, you're not going to crash into the homes because then I get in trouble. So what you're going to do, I'm going to open up this gate right here. But if you notice, here are the streets. Do you see the streets? Yes. So I said, so you're going to go up let me use black. 1 street, 2, 3, 4, 5, 6, 7 streets. So how many streets did they go up? 7 streets. And then I said, make a right turn, and then you're going to go 1, 2, 3, 4 streets to the right. 4 streets. How many? 4. And I even drew it here with my line. So instead of going through the houses, you're going to go 7 up, and you're going to go 4 to the right. And guess what? This fraction is what we call the rise over the run. Some of you guys remember, right? So once again, that's why, for those of you that don't remember rise over run, hopefully this little story will sink in, yes? Because we're about to get into graphing. Ready? All right, so get the big graph paper in front of you. Example Q, write it at the top, example Q, at the top of the paper. And I want you to write the instructions. Identify the slope of the line that passes through -4, -1, 4, and 3. -4, -1, 4, and 3. Write it at the top of your graph paper. The biggest graph paper. You have a medium one and a big one. Use a big one. So you're writing example Q. Identify the slope of the line that passes through -4, -1, and 4 and 3. All right? So let's do this one together. Here we go. I'm going to use blue, if you have blue. My first point is -4, -1. So let's plot that one. -4 of x, -1 of y is right there. So plot it on your graph paper. There it is. Next, we plot the second point. 4, 3. So we go to 4 of x, 3 of y, which is up here. Plot your other point. All right. So we're going to connect those points going from left to right. In mathematics, just like in language arts, we always read graph from left to right. So I'm going from here to there, yes? So sketch a line segment going from there to there. All right. So we said we're going to find our slope. So I want you to write m equals, I'm going to write the word rise over run. So, look at it. So if you want to give somebody directions, look up, going from this point to this point. Tell your neighbor, what would be the first direction you give? What is the first direction? Or in other words, what is the rise? Tell your neighbor, what is the rise? Then we're going to have Enrique pass it to someone. Mario, so to go from here to here, what are you going to say? If it was a map, you would say to go what? That would be for the run, yes, yeah. Up, how many? 1, 2, 3, 4. That is correct. So that is our rise, which is 4. All right, and then you said a right, and then how many blocks for the right? 1, 2, 3, 4, 5, 6, 7, 8. That is our run, and that is 8. So therefore, my slope, it says here, identify the slope of the line passing through the points. My slope between those 2 points is 4 over 8. And if we simplify that to lowest terms, that is what? 1 over 2. And from 1 to 5, how comfortable are you up to right there? It's coming back, right? Now check this out. Maybe something that you don't remember. Look up. So even though we ended up with 4/8, if I use this one, that is telling me that anytime I go 1 step up and 2 to the right, I should land on that line that I drew. Let's see. 1 step up, 2 to the right. Do I land the line? Yes, I do. 1 step up, 2 to the right. Do I land on the line? Yes, I do. 1 step up, 2 to the right. Land on the line? Pretty much, yes, and yes. That is correct. Woo-wee. All right. Turn your paper over. Do this one by yourself in the back. You don't have to copy the whole thing. Just copy the 2 coordinates. Example super Q. -2, 6, and 2, 3. Find me the slope of that line segment between those 2 points. Oh my goodness, slide. All right, do me a favor, check with your neighbor to make sure that they got the process down. They have the slope being the same as yours. If not, give them $5. All right, who went last? Mario? Mario, pass someone. Enrique, all right, tell me how to graph this. Where do I go? Starting at the center. -2 to the left. Up 6. All right, there's my first point. All right. Again, starting from 0, where do I go? 2 to the right. Up 3. All right, that's that one. And to graph the line, I always go from left to right. So I go from here to there. All right, so my slope, rise over run. I'm not going to write the words anymore. So if you give someone directions going from this point, since we're going from left to right, from this point to that point, what are you going to tell them to do, Enrique? Let me recap on the previous one. The previous one, Mario said go up 4 and then to the right. Okay. Okay, but we start either up or down. Down how many? 1, 2, 3. That is correct. Since we went down, it's -3. -3. And then? Four to the right. 1, 2, 3, 4. Hands if you got that. That is correct. Once again, going up is positive for the run. Going down is negative for the run. All right? Go to the next graph paper. One more. But this one, I'm going to give you an actual line. Copy this line, please. Label it example omega q. If you want to use the medium-sized one, that's fine. On the other paper. Let me zoom in. Copy this line onto your paper. There it is. All right, so here we go. On the previous 2 or 3 examples that we did, we needed how many points? How many? 2. But this time I only give you a line. Well, what do you need in order to find the slope? You need what? 2 points. So I want you to place 2 points on that line. It doesn't matter where. Now my suggestion is put them where both the x and the y meet every time the line passes by. For example, look up. Look at this point right here. You see how the x and the y meet right there? That would be 1 point. And now I'm going to use a different point. I'm going to use one down here. I'm going to use these 2. Now once again, does it have to be those 2? No, it could be any 2 points on the line. So with that said, let's find the rise over run. And once again, we're going from left to right, from left to right. All right. Looks like Gabriel's ready to go. Gabriel, if I need to go from this point to that point, what would be my rise? 1, 2, 3, 4, 5, 6. You're very close. No, it's 6 steps, but in what direction? -6. That is correct. -6. Okay. And then 1, 2, 3, 4. And this in lowest terms would be what, everyone? -3 over 2. All right. Hands if you got something like that. Now, did I have to use those 2? No. What if I use this one? These 2. Well, let's see. 1, 2, 3. That's -3. 1, 2. And that gives me that. So what are we saying? That just pick 2 points on the line, and you should have the same slope every time. Even if I use fractions, if I go in between here and here, fractions will get the same thing. All right? All right, from 1 to 5, hook up to writing with this. Yeah, we got it. Okay, so let's go to our notes. Go to your notes again. I want you to write this one on your paper. Make a new graph without any numbers. Hurry up, hurry up, hurry up. And label this an example MJQ. MJQ. All right, and we're going to start with 2 points. Here we go. Let's do 1 point here. And 1 point up here. My goodness. You guys hear? It's like they're speeding. Like some of y'all that are already driving. My goodness. All right. We good? All right, so once again, we need to find the slope. So on the right side, I want you to write m equals blank. All right, so check this out. Let's say this point has the x value of 2 and the y value of about 3. And this point has an x value of 4 and a y value of about 8. Okay. So I first need to give directions from here to here, so that means I need to do what? Find the right. Is that correct? So if I'm starting here, and I need to get to here, tell your neighbor how many steps. How many steps am I taking? How many steps? All right. How many steps? Joseph. Joseph said 5. Hands if you agree with 5. All right. However, look up, please. I want you to use these two numbers instead of just using counting with your fingers. If I was to use these two numbers, what would you write in order to get 5? Talk to your neighbor. What would you write in order to get 5? All right. Yulisa, what would you write? What can we do to these two numbers to get that? 8 minus 3. Write that in there, please. So with that said, let's go to the run. Now we need to get from here, look up. So now I'm about here. I need to get from here to here, which is from here to here. So what would be that new number? Tell your neighbor. New number. Caesar, new number. 2. Hands if you agree with that. And using this one and this one, what would I write, Caesar? 4 minus 2. Okay. So for the y change, we use this top number minus this one. For the x, we use the farthest x minus this one. Yes? Okay. We good? All right. So let's do it again. M equals. But this time, check this out. We're not going to pay attention to these. You don't have to erase them from yours. You can leave them there. But now I'm going to use this one being x sub 1 because it's 0.1. And this one would be y sub 1. So for this point, we have x1, y1. Yes? So for this second point, I'm going to label it what? X sub 2, y sub 2. So tell your neighbor to find the run to go from here to here. What would we write there? Talk to your neighbor. What would we write there? Like Mariah's got it. Very good, Mariah. I see you. Monse's got it. I see you, Monse. Jesus got it. Let's go, Jesus. Well, let's go with Gio. What would I write, Gio? Y sub 2 minus y sub 1. That is correct. Write that in there. So since he's in a row, what would I write for the run? That is correct. Box that, and this is the slope formula. Is it coming back? Yes? Hopefully your teacher approached it like that, showed you how to find the formula that way, which takes us to tonight's home plate. Copy this. Example 3Q. Find the slope of the line containing 2, 5, 8, 1. So write 2, 5, and 8, 1. And it says without graphing. All right, here we go. So, if we read this from left to right, which is my first point? The one on the left or the one on the right, Mario? Yes, so that means we're going to label this one x sub 1, y sub 1. Which means this one has to be what? X sub 2, y sub 2. All right, so I write my formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I write it again with blanks. Blank, minus, and minus on the numerator and denominator. So I'm going to use colors to stay organized. Ready? Here it goes. Y sub 2, which is what? 1, minus y sub 1, which is 5. Let's go to x. X sub 2. What is x sub 2? 8 minus x sub 1, which is 2. Here we go. What is 1 minus 5? That's negative 4. What is 8 minus 2? That's positive 6. In lowest terms, this is negative 2 over 3. You guys remember these? Yes? All right. Let's do another one. We still have 2 minutes. Copy this one. Negative 2 minus 2, 7, negative 2. All right, looks like Jesus got it. Very good, Jesus. Let's go with Joseph. What you get? Close. We have negative and negative, right? Y sub 2 is negative 2. Y sub 1 is what? Negative 2. X sub 2 is 7. X sub 1 is negative 2. Well, guess what? What is negative times a negative? Positive. Positive. This is 0 over 9, which is 0. Careful with those. Have a good one, everyone. Enjoy your home play. See you guys tomorrow. Bye.